Yeah, so we were discussing before that, yes, the electrons are going to get escaped if we just shine a light, a UV light on it. But you need a certain amount of frequency or a certain amount of energy that you give to that electron so that it gets escaped. We call that particular frequency as your threshold frequency. Okay? If you try the experiment described above with a bright filament lamp, okay, you will not find it has, you'll find that it will not have any effect on it. Okay? A normal bright filament lamp, not a UV lamp. Okay? It does not produce UV radiations. There is a minimum frequency that the incident radiation must have in order to release the electrons from the metal, and this is what we call as the threshold frequency. The minimum frequency you need your electron to get excited and to get escape from that particular metal. So now, the threshold frequency is property of the metal plate being exposed to the electromagnetic radiation, that at which particular frequency that particular metal electrons will get escaped. Okay? As I discussed this in the previous lesson as well, that it highly depends on with what type of metal you are using, how many free electrons are there. Okay? So let's define threshold frequency. It is defined as the minimum frequency required to release the electrons from the surface of the metal. Okay? Before that, the physicists actually they were unable to explain this, that you are using a very weak UV light. Okay? And still it was giving some emissions, whereas if you are just shining a very bright lower frequency light, but it was just not working. Before, it was like nobody was able to explain this particular phenomena. But obviously later on Einstein came into action and he explained the idea, that the idea is photon, and he said that for one photon, one electron. Okay? So photons are what? These are the energy packets. So you need your photon to be that much energized that it can take your electron and just walk away. So it has to carry that amount of energy. Okay, let's keep on reading. The physicists found it hard to explain why weak UV radiation could have an immediate effect on the electrons in the metal, but very bright light of lower frequency had no effect. They imagined light waves arriving at the metal spread out over its surface, and they could not see how weak UV waves could be more effective than the intense visible. So they were unable to basically explain that why this phenomena is happening. So the Albert Einstein came up with an explanation based on the idea of photon, which we'll study today as well. And like over here, they are just explaining that why they chose zinc, because obviously it has lightly held electrons in it, and the conduction electrons, and they are free to move. That's why they have used zinc. So this diagram is actually explaining it all, that when the UV light is just hits the zinc plate, the electrons on the surface of the zinc plate, they are actually breaking free and they are escaping. Okay, so this particular diagram is showing the whole phenomena, that what is actually happening here, like this particular, like if you want to draw it like this. So what is that? Okay, now let's move forward. Let's move forward here. Okay. Now, it has many important observations, students, so be very, just listen very carefully. Now, what Einstein proposed. Einstein said that don't picture your electromagnetic wave as, like a wave. He said that instead of it, just consider it a stream of like photon. The photon is actually targeting your electron right now. Okay, so Einstein did not picture the electromagnetic wave interacting with all of the electron in the plate, that a wave is coming and it's interacting with all. No, he said that there is one photon which is going to take one electron and just capture it and just escape that particular electron. So the photon energy would need to be at least as great as, he just named it as phi. And he said that if your energy is, if your photon energy is phi or greater than phi, then yes, that electron will get escaped. Okay, by this photon, Einstein could explain the threshold frequency, because he explained it that because he is not saying that it is a wave and it is going to spread on your particular plate and then the electrons are going to get escaped. No, he said no. Your photon energy has to be powerful enough to take that electron to escape from that particular plate. When a photon arrives at the metal plate, it may be captured by an electron. The electron gain all of the photon's energy and the photon no longer exists. The electron is going to capture the whole energy and now there is no photon. So what is left? The escaped electron and the kinetic energy. Don't forget the kinetic energy. Okay? So some of the energy is needed for the electron to escape from the energy well, and the rest is the electron's kinetic energy. Now we can see that the photon model works because it models electromagnetic wave as concentrated packets of energy. Okay? So now he can actually explain everything. Okay? Now it can explain everything. Here are some rules of the photoelectric effect. Okay? Here are some rules of the photoelectric. Electrons. Okay, just a minute. Students, wait a minute. Okay. 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 Sorry guys, just hold on for a minute and I'll just resume.